So this is the same as the previous question, but now we have friction involved. So let's first draw our free body diagram again. There's our block. We have a force pulling upwards and to the right at 30 degrees. That force is equal to 40.0 newtons. However, we also have that normal force going upwards, force of gravity going downwards. We have one extra force. We have a force of friction opposing our direction of motion. So friction force always opposes the direction of motion. So this one, in order to solve for the acceleration, we actually have to look at the y direction first. So we remember from the previous one, we saw that the sum of the forces in the y direction must equal to mass times acceleration in the y direction. Again, because we know this thing is moving left or right, not up or down, we know this acceleration is equal to 0. So net force in the y direction is 0. What forces are acting in the y direction? We saw that Fn is upwards, plus we have that 40.0 newtons sine 30 degrees minus the force of gravity. So we solved for this and we got the value that Fn was equal to 78.1 newtons. Now that we have normal force, we can actually solve for the x direction. So in the x direction, we can solve for acceleration. Get sum of the forces in the x direction is equal to mass multiplied by acceleration in the x direction. And instead of just having that 40 cos 30 degrees like we did last time, there's also this force of friction that is opposing this motion. What we need to remember from grade 11 is the equation for force of friction. That's equal to the coefficient of friction multiplied by the normal force. Okay, in grade 11 we always just said that normal force is mass times gravity, but that is not true because normal force is based on, you have to look at the scenario, look at the free body diagram and actually solve for it. So now we can actually plug in our different values. We have mass is our mass is given to us to be 10 kilograms, so 10.0 kilograms multiplied by AX. 40 cos 30 was 34.64. And our friction force is just going to be the coefficient of friction multiplied by our normal force, which comes out to be 78.1 newtons. So we solve for this, 34.64 minus 0.2 multiplied by 78.1. And we're going to divide all of that by 10. We get an acceleration of 1.90 meters per second squared. And this does make sense because if there's no friction, it was going at around 3 meters per second squared, 3.5. And with friction, obviously it's going to accelerate at a slower rate.